All right, in the next part, we are going to work on solving quadratic equations when we have two terms. So when we have two terms and the x term is missing, the way we would solve is by keeping the squared term on one side and moving everything else to the other side. So essentially, we're getting the x squared term alone. So for this first one, I'm just going to subtract this 64 over. So we would have x squared equals negative 64. And then to undo a power, we have to take the square root of each side. And now that we know about imaginary numbers, we can take the square root of a negative. So we would have x equals, and then it's going to be plus and minus, because we always have a positive and a negative for the answer when we take a square root of something. And 64 is 8, and then because it's negative, we're also going to have an I. So this would be our final answer for that problem. So next one, same idea. We're going to get the x squared term by itself. So we're going to subtract the 100 over. So 4x squared equals negative 100. Divide both sides by 4. So x squared equals negative 25. And then we are going to take the square root of each side. So again, the square root of 25 is 5, and it's going to be plus and minus again. Because remember, I can take 5 times 5 to get 25, or I can take negative 5 times negative 5 to get 25. And then the negative inside comes out as an I. So our answer is x equals plus and minus 5i. And we can write it another way. So if we have plus and minus, it means the same thing as saying x equals positive 8i and negative 8i. So you can write it as two separate answers. So same thing, this really means the same thing as x equals positive 5i and negative 5i. All right, our last example like this, again, we're going to start by subtracting the 49 over. So we'd have 25x squared equals negative 49. Divide by 25. And we can't simplify that, but that's okay because 49 and 25 are both perfect squares. So when I take the square root of it, we can take the square root of the top number. So we would have x equals plus and minus. So the square root of 49 is 7, and then the negative is the I, and then the square root of 25 is 5. So we're just going to have a fraction as our answer. And again, this means the same thing as saying positive 7i over 5 and negative 7i over 5. So you can choose to write it however you want. All right, the next part, it says to find the values of x and y that make the statement true. So looking at this, we are dealing with a complex number. So remember, a complex number is made up of a real number and an imaginary number. So looking at this, here's the imaginary part. So really, this part has to be equal to the imaginary part. So we're really solving y minus 3 times I equals 6i. And then that means that the rest of it, so this 3x minus 5, has to be equal to that real number. So as a separate problem, we're going to solve 3x minus 5 equals 7. So this first one, well, our i's really just kind of cancel out because we can divide both sides by that. So we're really solving y minus 3 equals 6. So we would add the 3 to each side. So y has to be 9. And then for this one, we're going to add the 5. So 3x equals 12, and then divide by 3. So x equals 4. And then just to double check to make sure that we did it right, if I substitute 4 in for this, 3 times 4 gives us 12. So 12 minus 5, so that's going to be 7, plus, and if I substitute the 9 in, so 9 minus 3 is 6i. So we have 7 plus 6i, which is equal to 7 plus 6i. So these would be my two answers to make the statement true. Okay, so again, if we try another one, so this is the real part of my answer, so we're going to take that 5x plus 1, and we're going to set it equal to the real part on this side. So that's going to be equal to 2x minus 2. And then here is the imaginary part, and we're just going to ignore the I because it's going to cancel out anyways. So we're going to set this equal to the other imaginary part. So 3 plus 2y equals y minus 6, and then we just solve each problem. So for this one, I'm going to subtract the y, and I'm going to subtract 3 at the same time. So that cancels, that cancels. So that will leave us with y equals negative 9. And then for the x, I'm going to subtract the 2x. And at the same time, I'm going to subtract the 1. So that will leave us with 3x equals negative 3. And then we would divide by 3 to get negative 1. So my two answers would be x equals negative 1 and y equals negative 9. And that will make the statements true.